Thank you very much for the introduction. Good morning, everyone. Today, I have to deliver this talk in English. I can do it in Mandarin, but struggling a little bit. Cantonese will be near impossible. Okay, now this talk maybe a little bit new to some of you. The others, they may know what it is all about. But I think you all know what is digital twin by now, because digital twin has been around for maybe 20 years. It has been applied to different areas for diagnostics, for monitoring, and later on, it actually has been used in healthcare as well, and also to monitor traffic. And in fact, in Europe, there is a project using digital twin to monitor the entire weather pattern in Europe. But that's, of course, it's a very big project. I'm not talking about that to begin with, okay? Now, self-introduction a little bit. And I do have a Chinese name. A Chinese name is here. And I'm fellow of a couple of institutions and then visiting professor of a number of universities, mostly in China, and look after two journals, IJAMT, Advanced Manufacturing Technologies, and Advances in Manufacturing. But this photograph, of course, is during my younger days. Now look much older than that. But again, I've taken a different look now. Now this is a computer-generated avatar. Now my avatar looks like this. So when I appear in the metaverse, that would be my look. Okay. Now let me give you a little bit of background on metaverse. Now metaverse actually has predecessors. And it has been around also for quite a while. And then it started with Neil Stephenson. Now, Neil Stephenson actually, he published a novel, a science fiction called Snow Crash, and in 1992. So in this novel, he described something called a metaverse. Now, metaverse actually, meta is a Greek word. Meta means beyond. First, universe. So metaverse means beyond the universe. Now, many movies have been made on this topic, and then all of them say that metaverse is a parallel universe. But in this talk, actually, I'm not going to touch on the science fiction part of it. Okay. Now, but of course, all of you know this Second Life, right? Second Life has been very popular. Maybe about 15, 20 years ago, lots of people play with it. And this is kind of an escape from your present day life into a world with all the fictitious figures, including the player himself or herself. You go there, you meet new friends, and you're very exciting because, you know, it's really a second life. You can trade things, you can talk to each other, share secrets, and so on and so forth. So this Second Life actually very popular. And right now, I think not many people play this any longer. But similarly, this may not be so well known. It's called Habbo Hotel. Now, Habbo Hotel, again, is a kind of a similar kind of a social media interactive virtual world. There are lots and lots of people staying in that hotel. It's called a Habbo Hotel. And inside here, you could interact with different people, exchange ideas. Very exciting, right? Now, metaverse itself, of course, it's about escaping the real world. You will escape the real world into a virtual world called metaverse. But digital twin is a little bit different. Digital twin is about making the real world better. You use a digital twin to monitor, to control. So it's a different concept. Although this is not my definition. This is actually by Mike Algan, who's the computer world executive. So he depicts this kind of a scenario. So a metaverse requires a level of immersion. Typical immersion is you wear this head-mounted device. Right now, the most popular, of course, is the Oculus. Oculus is pretty expensive, few $1,000s US. And then through the Oculus, then of course you enter into a virtual world, okay? So metaverse requires a level of immersion that digital twins do not. So upfront, I must state the difference between digital twin and the metaverse, but how digital twin is slowly merging with metaverse to form an integral part of it. So metaverse allows humans to interact dynamically in an environment made up of digital images. It's actually quite exciting. Now, before I go further, first I want to introduce to you the different elements of metaverse, right? Metaverse actually consists of many, many different elements. Now, some of these elements you may already be very familiar with. It's actually a fusion of different technologies, such as digital assets, AI and machine learning, social media, cryptocurrency, augmented reality, virtual reality, and social media, and so on, okay? Now, first we talk about digital asset. Now, digital asset in metaverse actually is the digital twin, okay? That's digital asset. So digital twin, I said, I will not spend too much time going through it because digital twin by now is actually a pretty mature technology. I would say pretty, not quite. Yet a lot of developments are still going on, but everybody knows what is digital twin. Now, to put it in a very simplistic description, a digital twin actually begin with it's like a CAD model. Now you have a real object, you create a 3D CAD model in great details, right? Then after that, you have all the sensors on the real model. Now the sensors will send signals to this digital twin. And therefore, when you are applying a force on the real model, you can see the digital model of digital twin being deformed and so on. So by using this, you can monitor a lot of things, which is really quite exciting, okay? Now, initially, this technology actually was applied to a single machine. In other words, you have a motor, and then you build a digital twin of the motor, right? So you can monitor the performance of the motor. And then according to Greaves, he actually sort of known as the father of digital twin. And he depicted the evolution of digital twin here. First, traditional digital twin, it started looking at a single component or single product. Then it has become a more complex product. And then after that, you can have a one-to-one correlation with a real scenario. In this case, could be a rocket. And then the next one is a digital twin platform. A digital twin platform is a replication of an actual object using a well-developed platform. And then at the moment, it's called IDT. The IDT is the intelligent digital platform, okay? It actually uses a kind of a concept is called front-running simulation, FRS. Now, this front-running simulation actually is sort of a kind of a predictive what is coming. Now, it was said, in F1, Formula One car racing, a digital twin was built of a particular race car. can't remember what it is, whether it's Ferrari or something else. And interestingly, the track where the car is racing on, it also converted into a digital twin. So they can predict roughly what is going to happen when the car turns around, when the car is running at a certain speed, to go around the corner. They will say that whether there's any chance of crashing or not. Okay, so that can do the job very well. But of course, what you cannot do is to monitor the driver. Now, suddenly the driver, will pull the muscle or something, then it's very difficult to do that. In time to come, it's possible because the driver, we can put sensors on the driver. So the driver is going to have a heart attack. The signals will come. They will know that this car actually could be in kind of a danger, right? So you're going to compare the digital twin right now with the intelligent digital twin. You can see that the difference is right now is passive, but IDT is active, and then offline against online, and goal given and against the goal seeking can find its own goal, and this is what we call the FRS, front running simulation. Okay, so it's predictive, and this one is anticipative. You can anticipate what's going on. So just now I mentioned that it's a digital asset. So the next one will be augmented reality. Now, augmented reality also is a very mature technology by now. It started maybe about 30 years ago. My group actually has spent close to 20 years working on this area, published a number of papers, books, and so on and so forth. And augmented reality is a step beyond virtual reality. Now, virtual reality actually is all computer simulation. Everything is virtual. But augmented reality is you put computer-generated text, graphics, video, and so on, superimposed onto the real object. But then, of course, you again need to wear some kind of a head-mounted device. So when you see through the head-mounted device, you see the real scene. You can also see the video, which is superimposed on it. Okay, but of course now researchers have overcome this problem. Get rid of the head-mounted device and develop some kind of a contact lens. I'm not sure whether it's comfortable to wear. I don't think it will be. I think looking at all the elements inside the contact lens. So this evolution is started with VR, virtual reality, then becomes AR, augmented reality, then the MR, which is mixed reality, then XR, what X stands for anything, right? Then we put up a new term called NR. NR means the next reality, what is yet to come, okay? Now this actually has been done by a Japanese company called Mojo Vision. They put up this contact lens. So when you wear it, you can see things superimposed. For example, for the tracker, you can see the map, the direction, and so on and so forth, and through this. But of course, if this should be able to switch on and off, right? Otherwise, it becomes very confusing. And when you're walking, you keep seeing the map in front of you, although you don't want to go there. So this becomes a lot of confusion. Okay, this is actually a good technology because walking around wearing a head-mounted device looks kind of strange. People will be staring at you. What is this guy doing? Whether it's some kind of a see-through device or peeping at people and so on, right? So this prototype actually is very much an innovation and an intersection of smartphone, AR, VR, smart wearable, and health technology. So this is very exciting. The next element is the digital avatar. Now, I think we all know Avatar from the cartoon, right? Of course, Avatar is non-existent. It's a cartoon figure. But the word avatar actually comes from Sanskrit. It means some kind of a deity descent from heaven or from somewhere else, and then came into English vocabulary in the late 18th century. Okay, the descent of a deity onto Earth. But of course, in the age of technology, an avatar is becoming a substitutional body of a person. Okay, so you can become an avatar in the metaverse. You can choose any face you want, you know. But for me, I have chosen this to be my avatar. It looks a bit like me, but this guy more handsome. So, okay, this is an avatar. Now, avatar has played an important part because a human cannot really operate in the metaverse. An avatar can. This avatar is actually a virtual figure. So right now, so what we are going to do now is human to train the avatar. So avatar becomes very skillful to learn from the human, right? And after that, an avatar can train, in turn, you can train the human. So human trained avatar can train a novice operator. And one other interesting thing is avatar can be equipped with all kinds of languages. All kinds of languages. Your avatar can speak Spanish, Italian, French, German, so on and so forth. It's up to you how to give it. So it's just like, nowadays it's smart mobile phone. You speak into it, you can translate and then produce another language. So this is quite possible in the case of an avatar. So we are going to explore this kind of facility in a metaverse. So another one, AI and machine learning. Well, this is a hot topic. Every university I visited, everyone is talking about AI and the data science development. And actually, to be honest, to the academia, to the teachers, to the professor, it's kind of a nightmare. You know why? Because the students' essays, probably even thesis, are generated using ChatGPT, using some kind of AI and so on. So now my university has made it very strict. Students can only use AI to learn for fact finding, but they cannot use AI to write a report. If they find out that student is using AI to write a report, that will be a failed grade. This is very serious. Actually, it's not too difficult to detect. The worst thing is nowadays a paper submitted to a journal, and a lot of them are actually AI generated. And AI generated uses very strange English. You can detect it. And then the publisher described the language to be terse, very terse language, and very unusual kind of description. And so now they are using a software to detect a paper which is written using AI. Okay. AI in engineering, I think we all know this AI can be in business engineering, can be in solutions engineering, provide solutions, new processes, and also AI platforms engineering. So this part actually also quite well established. The next one is again on AI and machine learning. I think right now we know that machine learning can be classified into three types: unsupervised learning, reinforced learning, and also supervised learning. Now, each one has different applications and different areas, and then lots of new tools, ideas have taken place. And now they are talking about LSTM, long short-term memory, observer, transformer, bidirectional LSTM, CNN, deep CNN, and so on. Those are actually all tools. When a paper is submitted to a journal, they use this kind of tools. I often ask myself, is there real value to that paper? I mean, those sciences are not developed by the authors, they already know. So the authors are using those tools plus some data to write a paper. So it is a useful paper. I'm not sure, I'm not sure whether it's a useful paper or not. It's just like 30 years ago, everybody submitted a paper using finite element. right? Finite element is also just a tool, right? If you use finite element to write a paper, so what is the big deal? You just analyze the data. Previously, maybe using some other ways and so on. Now using finite element. So again, those paper, you can say that they don't have real scientific contribution. If you are inventing new AI tools, of course, I say yes. Now that is a contribution. But using AI tool as it is to write a paper, it's not a real contribution. Okay. Blockchain. Blockchain is again very exciting. This has been used quite a lot in the commercial transactions and so on because of a very high security. Now, blockchain is some information can be added but cannot be deleted and so on. So this is actually to ensure that the system will not be corrupted by one we call a bad actor. One bad actor come in and can destroy the whole thing. So associate blockchain with Bitcoin, I will come to that later. And then, of course, in the Bitcoin, which is a kind of a cryptocurrency, you need to have very high security. Otherwise, people can enter your ledger, change your figures. In one night, you find out that it's completely being empty out. So all your saving will be gone, right? So blockchain is another technology which works together well in the metaverse. Interesting thing is there's a very decentralized kind of a nature. There's no single point of failure that could take down the entire database. That's the most important. Next one is the infrastructure. Now, infrastructure is very important. And all these depend on very high speed computation, communication, and so on. So right now is 5G. Soon, you'll be 6G. And China already announced 6G is coming. Right? 2030, 6G is expected to be launched. Okay. Again, it will meet some resistance from some country. I remember when 5G appears, there were opposition from countries here and there. So I expect when 6G is going to be launched, similarly, there will be some opinions about this. Then cryptocurrency is also very important. I don't know how many types of cryptocurrency you are aware of. This one, of course, we all know, the Bitcoin, right? Ether, not many people know about Ether. Ether actually is the second largest cryptocurrency. Dollar Robot, this is actually created in Meta Factory. This one, playing games. You play Angry Bird, this is the bird coin, right? I don't think anyone one of you play Angry Bird. But tell you honestly, I'm an avid viewer of Angry Bird. I just can't wait for the new game to come and destroy all of them and get the bird coins. So this is another type of cryptocurrency, okay? Cryptocurrency is a digital currency designed to work as a medium of exchange through a computer network. Of course, you cannot use USD, you cannot use HKD, you cannot use pound, you cannot use euro in this kind of scenario. So in the case of a computer network, you have to use cryptocurrency. Okay? The individual coin owners actually can record and store in the called a digital ledger, and then it's highly secure, and all transactions are done using blockchain, right? So there's a Bitcoin, there's a Ether, this is a Meta Factory governance token called Dollar Robot. This is Angry Bird Friends, Bitcoin. Now, 4 key innovations of Metaverse. Firstly is the Web3 technology. It uses it. And then spatial computing. Spatial computing, to a large extent, refers to AR, VR. And then a digital twin of a person and a digital twin of a customer. So this can also be constructed, and then they can correspond to one another. So Web 3 is new. I think Web 1 we all know, basic web pages, HTML, e-commerce, Java. Then Web 2 is social media, global internet access, web applications, data, monetization. So at the moment, we are very much in Web 2 and moving into Web 3. Now, Web 3, you have NFT, non-fungible token, you have semantic web, you have the metaverse, AR and VR, you have blockchains, AI, and interoperability. Okay. Web 3 and the metaverse, you may ask questions. What is the difference between Web 3 and metaverse? Because they almost appear at the same time. Okay, so Web 3, actually what happened is uses blockchain technology, and so is actually metaverse. But Web 3 and metaverse are two distinct concepts. The purpose and approaches are different. Metaverse refers to a virtual world. Web 3 actually is an evolution of the internet. Okay, so that's the difference. And later on, I'll show you a table. Metaverse is a standalone platform, and Web 3 is actually an evolution of the current internet infrastructure. So comparing Web 3 with Metaverse, here you can see that Web 3 is a new iteration of the internet, focused on creating a decentralized web. Users can own and control the content and assets they create. This actually comes to the concept of a DAO, decentralized autonomous organization, DAO. DAO actually is very much the concept behind Metaverse. Okay, now blockchain and cryptocurrencies are common features. Then here you have DAOs, you have NFT, non-fungible tokens, and also decentralized finance, and an application throughout the web. In the case of Metaverse, it's a digital space that could blend virtually augmented physical reality with physically persistent virtual reality spaces. Okay, and then connectivity technology is there, human interface is there, decentralized technology, one of the important elements, experience creation. Now this part is yet under development. So you say Metaverse relatively new, but the forecast is that Metaverse is something going to stay for the next many years. Now this term I want to mention here is something called a Meta Factory. The Meta Factory actually, there are a few versions of Meta Factory. The first version is one word, capital F. Now this Meta Factory has been around for more than 10 years. At the moment, it's doing a lot of trading, selling garments, shoes, that kind of thing. We call it a Meta Factory, but not the true sense of the Meta Factory. The research group in our lab is trying to develop. Okay, our lab trying to develop a Meta Factory within the Metaverse. Okay. Now, typically, it's sits on the intersection of community, culture, and finance. Okay, and then the monetary unit they use is called dollar robot. Very strange name, and the Meta Factory governance token. They claim that this is after many years of study. They come up with this token. So you use this token to buy things and trade and so on and so forth. It's the Meta Factory. And DAO is something that I mentioned earlier on, stands for Decentralized Autonomous Organization. Now this one actually, if you look at the figures here, traditional organization is you have a big boss, chairman of the board, and then you have managing directors, and then you go down to the next level, managers and so on. Now in DAO, it's decentralized. Okay, authority actually is spread to everyone. So this is actually an interesting concept. A group of people come together to pursue a common objective. Now, decentralized in nature and no central authority. There's no central authority, there's no board of directors, and then it's autonomous because it's by means of some kind of a smart contract, and etc. And then how do you decide who has more authority than the other? I mean, who has the bigger say, etc. I mean, even though they are not listening to a particular person, that depends to the amount of digital or cryptocurrency or shares they are holding. Okay. Keep that. Own government tokens. Actually, when it is a start, Bitcoin is considered as the earliest example of DAO. Bitcoin has been used. Of course, trading Bitcoin is exciting and also highly risky. And very often, the financial advisor will tell you, stay away if you have no confidence in cryptocurrency. So comparing the legacy organization and the Meta Factory, you can see that here, the chain of command comes from a top down, and this can be bottoms up, and it's sort of called decorative programming, and top down here is bottom up, and the bulk of ownership comes to be entrenched shareholders. Here, the ownership is contributed by the people who actually hold the tokens, and then so on. And then there's a blur lines between customers and owners. And here, of course, the strict separation between customer and owners. Okay, so this is the difference between the Meta Factory or the DAO and then the legacy organization. Now, something quite exciting is Hyundai, Unity, they have a strategic partnership on a Meta Factory. Now, notice that this Meta Factory is spelled differently. There's a space in between them. It's not the same Meta Factory. That one has already been operating for 10 years, and that is trading with garments and so on and so forth. And this is a kind of a Meta Factory, which they think is the setup in the Metaverse space. Now, this actually has been set up in Singapore, and 2 years back now, and MOU have been signed by high authority people, and you can see this guy is a new Prime Minister of Singapore, Lawrence Wong, and this is the top CEO from Hyundai, and they signed this MOU, and to supply equipment, facilities, surveys, and so on. They call it a Meta Factory. But of course, not to the extent that Hyundai cars are rolling out of this Meta Factory. Not to that extent. More on providing services, supplies, and so on. Okay. Now, Metaverse can be applied to healthcare. This is actually quite exciting, and there's something to come. Right. They're very innovative solutions for medical training, mental health support, public health, education, and so on and so forth. And then, of course, integration of Metaverse technologies such as AR, VR, those are the pillars of Metaverse, and then become very exciting. Now, this is kind of a schematic illustration of a Metaverse-based hospital bed. Now, this is, I think, quite futuristic. You have a real patient, you have an avatar, you could compare the performance, you could monitor the data collected, and so on and so forth. So this one actually is futuristic. You walk to a hospital today, you will not be able to see this yet. But they feel that by doing that, all the information can be centralized. But nowadays, it's already quite true. You walk out to see a GP. The GP, of course, has a password linked to all the hospitals and other clinics. And the GP will know exactly when did you take your last flu jab. Everything is transparent. You cannot hide anything. You fell down, you went to hospital, you broke your leg, you get a bandage up. All this information are stored in the computer. So in that sense, our medical information is already transparent to all the doctors. All they need is just to key in a secret password. You can access the information very easily. Social digital twin. This is an effort between Fujitsu and Carnegie Mellon. This is actually also very interesting kind of thing. They first started this by monitoring the traffic situation, right? Traffic situation actually is easiest to monitor. You just monitor the flow of the cars. You monitor where are the traffic jams. That is the easiest. That's already been done. But you want to go one step further. You want to monitor each and individual driver. But this is something quite exciting. You monitor the people and the vehicles. The people part is exciting. All right. Car just moving around. This guy driving the car, you don't know whether he's in a bad mood or good mood, what way he will do next, and so on and so forth. So by using the kind of social digital twin, you can actually monitor what's happening. Okay. It digitally reproduces the relationship and the connection between people, goods, and the economy and the society and so on. So the digital twin for social network is interpreted here. And the smart city service, high performance computing is needed. And then you use 5G or 6G for high-speed network. So city connected, facilities are connected, and so on. So where are we adding digital twins on the new many forms? Now, these three things are actually definitely merging: digital twin, generative AI, and metaverse. Okay, so these three technologies eventually will be combined. This already mentioned early on. I will not repeat here. Metaverse is a digitalized copy of the real world. Digital twin actually is a virtual representation of an object system. And then Mark Zuckerberg, actually, he changed Facebook into Meta, for seeing that the time to come, it will be a Meta. So no more Facebook, okay? Meta digital twins. This is actually aggregating digital twins. Build many digital twins together, made up of hundreds of other digital twins. So then you can be used to represent a very complex scenario. Okay, Europe, as I mentioned, they have a huge initiative 2 years back. They call it Destination Earth, with the goal of creating a meta digital twin to represent the various aspects of Europe, infrastructure, social fabric. Very interesting development called digital twin computing. Now, this is interesting because, digital twin has been developed in many, many different places, research institutes, factories, and so on and so forth. Each one of them uses different tools. So in the end, what happens? One digital twin cannot communicate with another digital twin, right? Now, this, we can think back 30, 40 years ago, when people started to develop CAD system, CAD system. CAD system, when they were first developed, they cannot talk to one another. A CATIA system cannot talk to SolidWorks and so forth. And of course, eventually people come up with a neutral format. Neutral format is like a kind of a translator or interpreter. You send your graphics information to that neutral format, and it can be converted into other neutral formats. So this actually is the kind of thing that people are now talking about. How can we, as a digital computing language, digital twin computer language, so that then eventually the digital twin created can talk to one another. Okay, this initiative is done by NTT a few years back in Japan. It's a project initiated by NTT, and they allowed diverse digital twins to be used across various sectors. So this is actually an exciting project to watch out. Another exciting project is called a human digital twin. Now, human digital twin, when it was first mooted the idea, it's put sensors on a person. This actually was more like for health monitoring. Person with a history of a heart problem, the pacemakers everywhere, and when you have sensors. And this signals, of course, will be sent to a clinic, a medical doctor, right? So you know when the patient is okay and not okay, and so on and so forth. And then they can construct a digital model of that patient. So looking at a digital model, you know whether the patient has been over exercising or is sleeping all the time and so on, heart is extremely low. So this is kind of thing. In a way, it's called the initial stage of human digital twin. But nowadays, human digital twin actually is more than that. They want to monitor the emotion of the person, you know, whether they are depressed, whether they are happy, and so on and so forth. So this actually become quite important, but it's kind of an intrusion of a privacy. Some people, they are depressed, but they don't want other people to know that they are depressed. They act as normal, right? But actually, these people are the most sad. They are depressed, but they want to act normal, right? There's a story it goes, you know, one guy went to see a psychiatrist, very depressed. He said, you know, why are you so depressed? Because many things didn't go along my way. And he said, you know, there's a circus nearby. You go and see the clown performing in the circus. You will be happier. The guy signed, said, doctor, I'm that clown. So he just can't help himself out, right? So you want to be depressed, you want to see somebody to release your depression, but he himself is that clown trying to help other people, okay? Now, cognitive digital twin as a next stage. This is also very exciting because digital twin all along have been passive. Now you want to make a digital twin active. A digital twin can plan for itself, think of itself as a natural language processing, data mining, and so on and so forth. So that digital twin become actually what's an IDT. You know, it was earlier defined. Also can be called a cognitive digital twin, right? A cognitive digital twin, the framework is shown here. And then you have online sensors, you have continuous adjustment, and then the hybrid digital twin is built together. And finally, you come out with a cognitive digital twin. Exciting project. Another term is called virtual twin. Now, virtual twin actually is not so much of a digital twin. This is actually a software by Dassault system, and it's simply a CAD, very detailed, very powerful CAD platform called CATIA. And then they borrow the word twin. It's all virtual, so it becomes virtual twin. I mention it here because the twin is used, but it's not so much to do with digital twin. It's a CATIA modeling system where they can produce very detailed description of a real object, and then to monitor the stresses, temperature, etc. Okay. Now, future capabilities of digital twin can proactively search for data, harvest data, and request sensors to capture certain types of data. Now, this is actually very useful because right now, sensors capture everything, right? Billions and billions of megabyte or whatever data, but most of them are not useful. So upfront, if you can filter off those not useful data, only capture the useful data you want, that actually makes a big improvement in storage, in processing, etc. And can develop its own model of the world and to become increasingly aware of the environment. This is the cognitive digital twin. And I can interact with other digital twins and with their physical twins at semantic level. Now, semantic level, that means you do not have to write complex codes, syntax for them to communicate. So in time to come, the programming will be very simple. Nobody need to learn Python, C++, and all those languages. It's become transparent to the user. Can play the role of proxy in the cyberspace, can represent the owner and represent the user, and also can replicate themselves as a need arises, creating instances you can add in parallel. Very exciting. Now, Destination Earth. Now, this is actually a project developed in the EU. I actually see whether it works here. What are the challenges ahead? Current development, mainly piecemeal solutions that tend to address a single problem, which is quite true. Anybody tell you that, I have constructed a digital twin, more than likely this digital twin is for a single piece of equipment. Okay, maybe a motor, maybe something else. And difficult to integrate digital twins developed over the time period. This I already mentioned, but if you use digital twin computing technology, that may solve the problem. And so there's a digital twin computing, is it a solution? And the same issues, some issues of digital twin development and advancement. First is the unified hardware and software protocols and interfaces. You must have some kind of a standard unified software and hardware that everybody can follow. But this is actually very difficult to force, especially the large organization, to follow a same kind of standard. Not to say complex things like digital twin. I mean, just the power plug. You travel all over the world. In Japan, they use this. Australia, you use that. And then in the United States, you use this. Nobody can standardize even a simple power plug. right? And I remember when I went to South Africa, they use a huge 3-pin plug, which I've never seen that before. So when I went to the shop, the guy knows what I want straight away. Take this out. You want this? This is it. Charge a fortune. I can't remember how much is more than 10 US dollars. But you need it, you have to buy it, right? So you cannot standardize the items. So in the case of digital twin, if you can standardize this, will be very much useful. Security issue is always a problem against various kind of malware. And let's say the more digital the world is, more virus attack, more hackers will get into your system. This one, we need to think about it. Now, communication of digital twins with human in cyberspace, that could be achieved by the Metaverse solution. Now, the journey of Metaverse, I could depict it here. It first started in 1991, The Snow Crash, as I mentioned, as a novel. And then idea developed and the proof of works, digital twin, it started here. And then it moves on. The Bitcoin was introduced in 2009 and blockchain also in the same year. And then Ready Player One, the games. And then an NFT, a non-fungible token, Ethereum network was invented. Oculus VR is here. And 2016, that's interesting. There's a Fortnite concert. Hundreds of thousands of people attended. And this was actually done using the Metaverse technology. Okay. And 2021 is a Microsoft Mesh was introduced. And then following year, Metaverse was introduced. So I predict that in 2025, it will be industrial applications of Metaverse, also in healthcare and social aspects of the Metaverse. I'll show you some very preliminary work done in our lab, depicting a simple workbench. He's wearing an Oculus. A flash of some of the books that me and my colleagues have produced. And this book is put together with Professor Fu Ming Wan. And I want to fill up those two spaces. And that's a cover of the translated book. I couldn't find it. Maybe Professor Fu can send it to me. Yeah, I think I saw his book in his office the other day. So my aim is to produce at least one book a year. At least one book a year. So you can see that this has been done over the last 20 years or something like that. Yeah, okay. And then these are the specific books on digital twins. The lead author is Professor Tao Fei from Beihang. He actually is very much into this area and then became an authority in China, if not in the world, on digital twins. Okay, so that comes to the end of the talk. I hope I didn't bore you a lot. Something relatively new, but it's coming. You know, you can foresee that this is a new kind of technologies we need to watch out and we need to be aware of. Yeah, I was wondering whether RIAM would consider using digital twin technology to run through all the clusters. because it can be used to monitor, control, you can centralize information, you can do a lot of things together. So then you can integrate all the various bits and pieces of different activities, right? So with this, thank you very much for your attention. Okay.